So yeah, I'm Eran Elbaz. I'm a full stack developer at NV0. We have a platform that helps you manage your infrastructure as code. And I'm a former OpenTofu core developer. So it means that for the last 4 years or so, I'm living infrastructure as code through managing it or developing it. And infrastructure as code, it's not ongoing. It's not a trend. It's how we today try to fundamentally manage our infrastructure and how to automate and codify it. And we'll talk about why do we even need infrastructure as code? How do we choose the right infrastructure as code tool? How do we manage it based on our organization infrastructure as code maturity? And some notes about how we believe the unified DevOps process. Anyone here is familiar with infrastructure as code by raising hands? Wow, most of you. Nice. So as probably most of us know, our applications are much more complex today than what they were when we started to work. I remember when I learned computer science, then we used to have like a basic virtual server with some load balancer that talked with SQL server. And it was enough for most of our usages. But today we have virtual servers, we have pods and containers, and we have maybe some serverless applications that we try to use. Everything is inside our cloud, and we try to protect it with multiple layers of security. And trying to deploy from ClickOps, as we like to call it, where I go into the AWS console, for example, and I decide that I want to deploy a EC2 instance, and I give the relevant configuration to it, then it becomes really hard, because if I want to deploy a new stage, then I need to remember everything. And most of us, if we were DevOps back in the days, then we had like a long document on how to deploy a new stage. And we used to update it every now and then, and it was enough. Today, if I want to keep this document up to date, I need to do it almost daily. Because if now I, let's say, manage Kubernetes resources and I want to deploy a new service, I need to update this document. And I need to do it again and again each time. And this becomes a tedious task. And instead, we can use code to do it. We all probably learned that the code is our documentation. And so let's use it. This is just like a Terraform example, where I can deploy some EC2 instance. And instead of clicking in AWS console, I can do it via code. And this is today become the de facto standard of how to manage our infrastructure. And lots of us believe this is crucial for modern day cloud native operation and best DevOps practices, because we can now automate the deployment process and to seamlessly integrate it as part of the dev lifecycle. We can get consistency and accuracy in our deployment to the cloud, because if today I have a production incident, for example, and it's in 3 a.m., everyone is tired, and we decide just to bump the run. But we forgot to update the documentation we talked about. Later, someone wants to deploy a new stage, and this someone takes production as the source of truth. And now he thinks to himself, wait, why in dev it's 2 GB of RAM and in production it's 4, and no one remember why. When you have it in code, then you have a commit message, you probably have a pull request, you know who did it, you know why this person did it. And as we can back to the fact that we can scale and manage our infrastructure better by the fact that it's in code, we can review it, we can go back in time, and we don't need anything else to manage it. So let's take a step in the history of infrastructure as code. where probably we began with some Bash and Python scripting that helps us deploy infrastructure to the cloud. But this took some turning point with CloudFormation and Terraform back in 2010 with the idea of declarative infrastructure as code. Because instead of me trying to understand how to deploy and how to communicate with, let's say, AWS, and how to handle conflicts, now I just tell, okay, I want EC2 instance, I want S3 bucket, and this infrastructure as code tool just do it behind the scene for me, and I don't need to know anything about how we deploy it to the cloud. This helps me to just take away all the hard understanding and lifting of the deployment to the cloud. Then with Pulumi and CDK, Pulumi was back at 2017, we took another turning point with the fact that now we can write the infrastructure as code as part of our code base. We no longer need to learn let's say for Terraform, we need to learn HCL. We no longer need to do it because now we can use it as part of our code base with TypeScript, to Go, .NET, etc. And we also get all the rich features of the programming language. And choosing the right infrastructure as code tool, it's a hard task. It's like choosing the right software development the program to write on. This is a hard task because I like JavaScript, someone else likes Python, another person likes C#, and it all depends on the task that we're trying to solve. So those are just like 3 criteria that I thought about, and there are many, many more. So let's take security and compliance. We want to choose the right infrastructure as code tool that stands with our organization compliance. Plus, we want to write infrastructure as code tool that can help us understand all the security practices and best practices out there, because no one wants to deploy secrets that are in plain text. Then it's not a secret anymore. Also, we want to consider scale and performance, because as our organization mature and our product become more and more complex, also our infrastructure become more and more complex. So we want the tool to help us manage the growth and the performance of the deployment process and of production, because we don't want to get to the point where we say, whoa, this infrastructure can't handle all the capacity of our product. And lastly, we want the tool to be easy to learn and to adopt. We can choose the best tool for the job, but learning it will take months. No one has the time for it. So we want something that our team knows how to handle, and we have some big community around it to help us learn, adopt, and overcome obstacles. So we're going into the infrastructure as code battleground. This is where we put like a cool theme song of some action movie. But we have overwhelming number of infrastructure as code tools available. Different tools have different strengths and different weaknesses. And as we just talked about, choosing the right tool is critical for our success. So we have round 1, which is Terraform versus we'll get to know in a bit. And today, Terraform considered to be the industry standard. It's cloud agnostic. I can deploy to AWS, GCP, Azure, Oracle Cloud. I can even order pizza using Terraform. And it has large community and ecosystem around it. But people consider it to be complex. We have no state encryption, so if I needed to deploy secrets, then it will be stored as a plain text. And we are vendor locked to HashiCorp, and we need to learn HCL, which is a proprietary language only for Terraform. On the other side, we have AWS CloudFormation. From the name we know, it's off AWS, so we have the best practices from the vendor. Plus, it's tightly coupled with AWS, and it supports only AWS. So if we are only deploying to AWS and we don't think we'll need any other cloud in the future, maybe CloudFormation is a good option for us. we don't need to manage the state. It's happening in AWS, which can be good or bad for us, depending on the use case. And as we talked, it's only support AWS. Then we have Pulumi. It supports Go, it supports TypeScript. It's part of our code base, so we don't need to learn anything new. It's also cloud agnostic, but it has only the default state management, which resides in Pulumi backend. And the community size and support, it's pretty limited because it is a bit of a new product. But on the other end, we have OpenTofu, which considered to be drop-in replacement for Terraform. It's true open source by the Linux Foundation, and it's by the CNCF. It has the same ecosystem as Terraform, so it's considered to be extensive. And in OpenTofu, unlike Terraform, we can have better state handling capabilities like encryption. So if we want to deploy lots of secrets, maybe we want to choose OpenTofu instead of Terraform. But it's relatively new, and it has a smaller community. But a lot of people start to adopt it. Then if we talked about how to deploy resources to the cloud, we need to talk about how to manage, how to configure those resources. If I deployed EC2 instance, it's nice, but I need a way to do git clone and run my application. So we have Ansible, for example, that we can use YAML and so we can use YAML and Python to configure it. It's agentless. It publishes changes by connecting to the endpoint by SSH, which again might be an issue for some of us or not. And it has no state management at all. And we have Salt project, which is a server client configuration. Then we need to manage agents. It doesn't publish by SSH, but now we have the overhead of maintaining agents and manage their updates. We do have a state and configuration management, but we're currently in the unknown after the acquisition of VMware and Broadcom. So who won? I don't know, because same as software languages, there is no one single best. It's all dependent on the context and the need. Like, what platforms are we currently using? We're only using one cloud, or we're using many? Where are we deploying to? What technologies are we familiar with? All of those are questions that we need to answer before we're choosing the right tool. And the best approach, in my opinion, is the multi-tool, because why can't we have both? Same as microservices architecture, where we can choose the right software language for the job. If I need input-output, then I'll probably use Python or JavaScript. And if I need something which is heavily CPU-bound, I'll choose Go or Java or whatever you guys are using. So we can leverage the strengths of each infrastructure as code. For example, us at Env0, we use serverless because we deploy a lot of Lambdas, and using serverless is pretty easy. But we're also using Terraform and OpenTofu, because creating Lambda using Terraform, it's a very hard task. You need to upload it to S3 bucket and then expose it, while using serverless, I just declare it in a YAML file. I can address diversity as requirement, depending if I use cloud native, if I use traditional or legacy deployment types. And I can facilitate the migration and integration strategies, because if I use ServiceNow integration, or I wanted to integrate to my version control or Jira, I can do it using different tools. And we can always consider in-house scripting for specific tasks, but again, those are in need for someone to manage it. And we want to understand our infrastructure as code maturity, our organization maturity, where we start with basic ClickOps. Because we only have 1 or 2 services, our team is pretty small, we don't need anything fancy. We can go into the Cloud Console, click on some buttons, and we'll have everything. But then we start to understand the productivity is not that great. And on the other end, maybe the governance is not that great, because if I give all the developers admin access to the cloud, then I have zero governance. But if I do it only via one person, which considered to be the DevOps of the company, then the productivity is very low. This is the point where we start to think about infrastructure as code, because we need a way to start and automate it, or by using scripting to deploy to cloud. If I do it via scripting or infrastructure as code, I can start to integrate it into my CI/CD process and then into the lifecycle of our developments. For example, if I create a pull request, I can write a Git action or Jenkins that will start to spin up environment for me. And when we merge it to master, I can use another action to deploy the new resources to the cloud. But then we start to think about governance, because we now have many and many of pull requests up. We don't know which resource belongs to which developer. We maybe have, let's call those zombie instances, where someone spin up an EC2 instance and then forgot about it, went to like a vacation, come back and just spin another one. We start to have a lot of resources in the cloud. Then we start to think about some extra product that help us automate the process to give the productivity back to our developers and keep us in better governance over our cloud and our resources. And in my opinion, this is how the DevOps process should look, where we write code, we write infrastructure as code, for example, Terraform or OpenTofu, and we want to push it into our version control. Then we have CI/CD processes on top of it to know that we don't introduce any security vulnerabilities. We didn't try to spin up big EC2 instance with a big GPU that will take our credit. And then we can have some approval based on the CI output via Open Policy Agent, for example. Then we can apply, get the logs, and monitor everything. So I will dive into some of the tools that I just mentioned. For example, policy as code. It's similar to infrastructure as code, but only for policy, where we have the policy of our organization. Instead of remember it by heart and manage it in documents, we can write it in code. And then we can codify the organization policies. We reduce the risk that I, as a human, as a reviewer, missed something when I need to review a big plan. And it also reduces the bottleneck, because I know I don't need to look into stuff the program already looked at. I can achieve it, for example, with Open Policy Agent, which is another open source tool that looks over JSONs and outputs and decide if to pass them or not. We also have static code analysis tools like Chekhov that can scan for misconfigurations. It can identify security vulnerabilities before we deploying. It can look over our plan and see, okay, you just deployed S3 bucket with full access to the entire world, which is not good for us. We can ensure the compliance with industry standards and internal policies. We can also write policies to Chekhov. And then just run the scan on it, and it will tell us if our plan is good or not. And we can also use some cost estimation tools, because the cost of our cloud provider is out there. We can use it and read the plan and say, okay, we decide to deploy 3 EC2 instances, and we know the cost of those EC2 instances where they're up. I can say, okay, this deploy will cost more $10, $15 based on the changes that we did. So if we are summarizing everything, we have no single best infrastructure as code tool for all scenarios. We might want to use multiple tools and combine them together. The winner depends basically on us and our organization, how much our product is mature, what is our technology stack, and the use cases. And we probably want to adopt some strategic and adaptable approach where we don't get too fully invested to a tool where later it can no longer help us. Questions?
I have a couple coming up on Slido. First, some industry chatter about OpenTofu and HashiCorp, if you can share anything.
So I didn't want to go very much into it, but basically OpenTofu is fork of Terraform. Each have its own community, and the products start to diverge between one another, where OpenTofu accept the community, its own community. It have its own roadmap, and those are they start from the same point, but now they diverge to different paths.
Mm-hmm. All right. What do you think about CDK for Terraform, if you have used it? Or
I actually didn't use CDK personally. Sorry.
All right. And there is one more coming in. Okay. Hold on. This one.
So yes, we at NF0 have a feature that uses GenAI to help us generate infrastructure as code from existing resources, for example. It's thing that starts to rise. There is also other tools around that help us write infrastructure as code, like Firefly, using GenAI. Some are better, some are not, but it is a trend that starts to get more into shape these days.
Do you let those changes into production without looking at it, or it's more like human assisting?
It's more like human assisting. Mm-hmm. We at NF0, we help you generate the code if you want to migrate between the ClickOps and Terraform or OpenTofu. But then it's for the developer to look and make sure GenAI didn't do anything harmful for us.
Mm-hmm. That makes sense. OpenTofu again, support for open cluster management policy, the top one.
We can check later.
Yes, you are going to be around, I suppose.
Yeah, I'm going to be around, I think, here somewhere.
Okay. OpenTofu is a very popular topic these days.
Yes.
All right. Maybe one final one. Do you have any tips for drift control?
So you can run drift by running the plan for your infrastructure as code and see the drift that it have. Drift is mainly when someone does manual changes to existing infrastructure as code. To manage it, you can either educate your developers or drop their access. It's basically a human error. You can call it a human error, but it's human action that people do to change stuff maybe before they make it to their infrastructure as code or by mistake. So basically to educate the people that you work with.
All right. Unit testing, infrastructure as code. Do you have any experience?
So I know that for Terraform 1.6 and OpenTofu, there is a testing feature. I help writing the testing feature for OpenTofu, which let you write some sort of unit test to your infrastructure as code before you deploy it. This is a great feature that we can utilize, the same as writing unit test for our own code, where if we have some conditions where we want to deploy to a specific region or not, so we can use this feature. Definitely try it.
All right. Thank you very much. I think Eran will be around for more OpenTofu questions. Thank you very much.